Hi everybody, welcome back to the Feynman Technique. This is problem 4 off of the 1999 AP Calculus AB exam. It is a free response question. I'm not sure if a calculator is allowed. I know it's not necessary. But anyway, the link to the problem will be in the description. I did not write the actual problem on the board just to save space. The problem is this. Suppose that the function f has a continuous second derivative for all x and that the following is true. We have f of 0 equals 2, f prime of 0 equals negative 3, f double prime of 0 equals 0, and g is a function whose derivative is given by this. G prime of x is equal to e to the negative 2x times quantity 3f of x plus 2f prime of x. Okay, so our part A asks us to write an equation of the tangent line to the graph f at the point where x is equal to 0. So this is where our first concept comes in. The equation to the tangent line, the line tangent to any point x on the graph f of x, or any point A on the graph f of x, is given by this. This is going to be the equation. So anytime they ask you to find the line tangent to a function at a point A, whatever A happens to be, in our case A is 0, it's given by this every single time. It's given by y is equal to f evaluated at a, the function evaluated at a, plus the derivative of the function evaluated at a, times x minus a. Okay, so how do we apply it to this? It asks us to write the equation of the line tangent to the graph at the point where x is equal to 0. Okay, so let's just write it. It's always going to be given by this. So let's copy that. Y is going to be equal to f at a. Well, what is a in our case? It says at the point where x is equal to 0. X is equal to a is 0. So what is f at 0? It gives it to us. That's 2. Plus f prime of a, or f prime of 0. And it gives that to us also. It states it in the problem that f prime of 0 is equal to negative 3. This is just seeing if you know this. That's all this part is doing. It's just seeing if you know this. If you know the formula for finding the equation to a line tangent to a curve f of x at the point x is equal to a. So, in other words, continuing on, f prime at 0, it gives it to us, is negative 3. So, negative 3. It's about 3. 3. Times quantity x minus a. Again, our a in this case is 0, so that's x minus 0. All right, well, what's that equal to? That's just 2 minus 3x. And that's it. This is the equation. Y is equal to 2 minus 3x. And we're done. We're done with part A. That's it. And of course, you should show the work to get full credit. All right. So on to part B. Is there sufficient information to determine whether or not the graph f has a point of inflection when x is equal to 0? This is where our second concept comes in. These are the conditions for a point of inflection of f of x at, any point x. First, f double prime of x must be equal to 0. And second, f double prime of x has to change signs around x. In other words, as you approach the point in question, f double prime needs to switch from either being negative to positive or from being positive to negative. So let's see, does our problem give us enough information to to meet these two conditions for a point of inflection? Well, what about the first one? Uh, f double prime of x is equal to 0. It asks us, is there sufficient information to determine whether or not the graph of f has a point of inflection when x is equal to 0? Well, yeah, it gives us f double prime of 0 is equal to 0. So yeah, the first condition is met. F double prime at 0 is equal to 0. So yes, the first condition is met. Now, is there sufficient information to determine whether or not f double prime changes sign at x is equal to 0? There isn't. This is literally all the information it gives us. It does not, it only gives us f double prime at 0. It does not give us f double prime at any other values, nor does it give us a true expression for f in order to, find f double prime so we could determine whether or not it changes sign at 0. So, no. The answer to that would be no, because both conditions cannot be verified true. And then these are the conditions. So really on the test you'd say no, because we cannot determine if f double prime changes signs around x is equal to 0. That's what you would write to get full credit. Okay. Part C. Given that g of 0 is equal to 4, write an equation of the tangent line to the graph of g at the point where x is equal to 0. All right, we're going to be using concept number 2 again, although it's going to be slightly more complicated than in part A. So, but it's going to be the same idea. We just need to plug it in. In this case, our function is g. So the tangent line to g at g is equal to 0 is going to be given by this. Y is equal to, well, we're working with g now, so it's going to be g of 0 plus g prime of 0 times x minus 0. Okay, well, let's clean this up a little bit. X minus 0 is just x. Okay. So, let's fill in the blanks here. It gives us, in part C, that g of 0 is equal to 4. All right. So, g of 0 is equal to 4. What about g prime of 0? Well, I mean, we're given g prime. To find g prime of 0, we literally just replace all these x's with zeros. So g prime of 0 is equal to e to the negative 0, or e to the 0. This is another concept you need to know, is that any constant raised to the 0 power is going to be 1. I'm not going to write that down because you should know that, but if you don't, you probably you should know that. Okay, so that's going to be equal to 1 times 3 times f at 0, or 2. 3 times 2 plus 2 times f prime at 0, which is negative 3. That is g prime of 0. e to the 0, 1, times 3 times f of 0, which is 2, plus 2 times f prime at 0, which is negative 3. Cleaning this up a little bit, we will get g prime of 0 is equal to 0. That's 6 plus negative 6. That's 6 minus 6. That is 0. 0 times 1 is 0. G prime of 0 is 0. So, what is this? This is g of 0, which is 4, plus 0. Y is equal to 4. So that is the answer. Y is equal to 4. Be sure to show all your work. Also, you know, state this. To get full credit, state this. And then plug in the values and just show all your work to get full points. All right. So that's the answer. For part C, the answer is y is equal to 4. That's the equation to the tangent line that they're wanting. All right. Part D, the most difficult one. Okay. Show that g double prime of x is equal to, and then it gives you something. All right. So, okay, we need to take the derivative of g prime of x. Know this. Know that g double prime of x is equal to the derivative with respect to x of g prime of x. You should know that if you're even contemplating taking this test. All right. So g double prime of x is going to be equal to the derivative of g prime of x. So with respect to x, of course. They give us g prime of x. So g double prime of x is equal to the derivative with respect to x of this thing right here. Okay, what do we have? Again, you need to be good at recognizing what sort of rule you need to use when taking a derivative. The easiest way to do that is just with a product rule on e to the negative 2x and 3f of x plus 2f prime of x. You could distribute this e to the negative 2x and then do two product rules. You could do that, but why? Why would you do that? So what we're going to do is we're going to do a product rule where our first function is e to the negative 2x and our second function is 3f of x plus 2f prime of x. All right, so product rule goes like this. It goes your first function, which is e to the negative 2x, times the derivative of your second function. This is very easy. I hope all of you know how to take the derivative of this. Even though, basically all you do to take the derivative of this thing, add a little prime there, and add an extra prime there. That's literally all you do. The derivative of f of x is f prime of x. The derivative of f prime of x is f double prime of x. So you just literally add another prime notation to each one of those things. And of course, you should know that the derivative of the sum of any two functions is just the sum of their derivatives. In other words, the derivative of this entire thing is the derivative of this plus the derivative of this. And the derivative of something multiplied by a constant is just that constant multiplied by the derivative. So, I mean, you need to know that. I hope you all do. All right. So that's e to the negative 2x times 3 f prime of x plus 2 f double prime of x. All right, well, there's our first times the derivative of the second, but we're not done with the product rule. We still need the second part. That is plus the second, which is just this. Our second function is 3 f of x plus 2 f prime of x. times the derivative of our first function. The derivative of our first function, this is going to be a chain rule. This is the derivative of e to the something, which is always, you always end up getting that something back. So it's going to be e to the negative 2x. You always get back, if you have e raised to the something, or technically anything raised to the something, you're going to get, if that something is a function of x, you're going to get it back. In other words, this is e to the negative 2x, but don't forget the chain rule. The chain rule says it is the derivative of the outer function. The outer function is the exponential function. That's why we just recovered the thing itself, times the derivative with respect to x of this thing you're raising e to. That is our inner function. And the derivative with respect to x of that is negative 2. So there we go. First times derivative of the second plus the second times the derivative of the first. All right, let's clean this up a little bit. Let's put this negative sign right here. I hope you agree we could do that. That's basic stuff you should know. This is all multiplication. You can just take that negative and put it right out front. All right. Next thing, let's distribute this 2 inside these parentheses. Again, this is something times something times something. Let's just put this 2 inside there. So this would become a 6 f of x plus 4 f prime of x. And if any of you are having trouble following what I'm doing, you need to brush up on your more basic stuff, because this is everything that I'm doing without an explanation is stuff you should know how to do to take this test. All right. So the next thing, what are we going to do? Well, we have this minus this. They both have a common factor of e to the negative 2x. So let's just factor it out. I'm going to put a bracket around that entire thing like that. And that is exactly what we had before. I just factored out that e to the negative 2x. Okay. So now we have, have we shown what we set out to show? Almost. Let's combine our like terms. How many f prime of x's do we have? Let's see. We have a 3f prime of x minus 4f prime of x. So we just have a negative f prime of x. We'll get rid of this. How many f double primes of x do we have? Well, this, just the one. I'm sorry, just the 2. And then we have minus 6 f of x. That's our only f of x term. So let's just go ahead and get rid of all these parentheses. So that's it. We just have g double prime of x is equal to e to the negative 2x times, well, there's our negative 6 f of x. There's our negative f prime of x. And there is our 2f double prime of x. So we just showed that what it asked us to show, well, we just showed it. All right, so let's clean this up a little bit. I'll just get rid of these square brackets because we don't need them being square anymore. And we'll just put it like that. So there's our g double prime of x. Part 2 of part D of question 4. Does g have a local maximum at x is equal to 0? This is where our third concept comes in. A local min or max of f of x occurs when a minimum occurs when both of these conditions are met. F prime of x has to equal 0, and f double prime of x has to be greater than 0. A maximum would occur at, or when f prime of x is equal to 0 and f double prime of x is less than 0. And let me show you why that's true. Okay. What does f prime of x equals 0 mean? Well, if you have some graph and it goes like this, f prime of x being equal to 0 is where the slope of this thing is equal to 0. Here, 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 and here. What does f double prime of x being greater than 0 mean? If f double prime is greater than 0, that means you have concave up. Concave up means that well, I mean, I guess in graphical terms, it means that if you only took the portion of this thing that was concave up and you dumped water into it, you know, it would hold the water. But basically, it's like the difference between a right side up cup and an upside down cup. It is concave up approximately like right here. You can see because it kind of forms a right side up cup. That's not a rigorous mathematical way of saying when it's concave up and when it's concave down. But for sure, you can see that this thing right here is concave up around this point, around the point where that derivative is equal to 0. So the reason why you would have a local minimum here is because, well, A, it is the f prime of x is equal to 0, and it is concave up. You can see that this is a local minimum. A local maximum is like right here, where our f prime is 0, and it is concave down. You can see that it's concave down here. Concave down kind of means that I mean, it's given by f double prime being less than 0. So again, a minimum occurs when f prime of x is equal to 0, like right here, and f double prime is greater than 0. It is concave up. A minimum occurs when f prime is 0, like such as here, and f double prime is less than 0, concave down. So that's kind of a graphical interpretation of why that's true. But you don't need to know why it's true. For taking the test, you just need to know that it is true. These are the conditions. A minimum occurs when f prime of x is equal to 0, and also f double prime greater than 0. And a max occurs when f prime is equal to 0, and f double prime less than 0. So, back to the question, does G have a local maximum? Okay, we're considering this. Well, is f prime at 0 equal to 0? Well, I'm sorry, is G prime at 0 equal to 0? Well, G prime of x is given by this. So what is G prime of 0? It is equal to, well, 0. I'm sorry, it's equal to 1, e to the 0, which is 1, times 3 times f of 0, which is 3 times 6, plus 2 times f prime at 0, which is negative 3, 2 times negative 3, oh, I'm sorry, this is just 6. This is 3 times 2, plus 2 times negative 3. In other words, 6 minus 6 times 1 is 0. Yeah, G prime of 0 is 0. So that condition is met. G prime of 0 is equal to 0. Well, in order to show that we have a local maximum, what do we need to show? That G double prime is less than 0. Okay, G double prime at 0 is less than 0, so let's plug it in. what is g double prime at 0? That's equal to e to the 0, which is 1, times negative f prime at 0, negative 2, I'm sorry, negative 3, which is just 3, plus 2 times f double prime of 0, which is just 0, so we'll ignore that part, minus 6 times f at 0, which is, let's see, f at 0 is 2, so minus 6 times that is minus 12, which is equal to minus 9. Did I do that right? Yeah. E to the 0 is 1, and then we have minus f prime of 0. Minus a minus 3 is a positive 3. And then plus, or I'm sorry, minus 6 times f at 0. Minus 6 times 2, it's minus 12. So yeah, that's minus 9. And that is less than 0. So we have met both conditions for a local maximum. That is at x is equal to 0 for our function g. That is that g prime of 0 is equal to 0. That's our first condition. And that g double prime of 0 is less than 0 because it's negative 9. All right, so both conditions are met. And then it says justify your answer. Of course, justify it by showing all this stuff. State this. State this in the answer to your problem. And then just say that it's given, well, then show your work for finding g prime of 0. Then show your work for finding g double prime of 0. And then say, yeah, the conditions for a local maximum are met because g prime of 0 is equal to 0 and g double prime of 0 less than 0. Therefore, a local maximum occurs at at x is equal to 0. And that's it. That's all 4 parts of question number 4 on the 1999 AP Calculus AB free response portion. Stay tuned for question number 5.